Thank you, Jamie, for the introduction. And ladies and gentlemen, also warm welcome from my side to the conference. I'm really happy to be here on stage second time, so last year to this year. And when preparing the conference, I asked myself, what changed within 1 year? So, okay, I got a beard, but if you take a closer look, or even from distance, there's gray hair inside. And that's because I think our automotive development culture did not change a lot. So we are somehow not very fast in that. And that concerns me really, and I think we are screwed if we don't change faster. So what else changed? In my team, we took over the software factory responsibility. Christoph Henning, he's also in the audience, took over, and he's part of my team, and I'm really honored to be here today to give a little bit more view on a software factory on an abstract level. By the way, is there anybody from purchasing in the room? Be brave, raise your hand. Nobody. What a pity. I asked the question last year at the end, and I still think, besides all the changes to another software development culture, we need another purchasing culture, which considers this long-term stuff, the software-defined vehicle stuff. So that's really, really a problem if we don't change that. So, and would be great to talk to those people at the coffee or at the lunch. But okay, and my speech is between you and the lunch, so I will try to speed up a little bit and to entertain you with those topics here. So we will go into the challenges, a little bit recap from last year, and a view to process methods tools from my side, and why we are screwed. And next thing is the software factory. So going from a single production to a real software factory. And I will close with, I would say, a big need to introduce model-based systems engineering as an example, and that the OEMs need to upgrade their, I name it, contract API. Okay. What was the challenge? This was a picture from the last conference with all the software-defined vehicle challenges. It's still the same. Architectures, enabling software-hardware separation, modern software development, our organizations need to change, and access to the full fleet. And today, we're going a little bit more into the software development stuff with the software factories as one key element. Also from the last year was a big change in our target system, what we develop, where we have the 3 big pillars: in-vehicle, connectivity, and the development environment on the right side below, needs another change in our organizations due to Conway's law. So we need to change our organizations. And that's really a core requirement. And I don't see this happen so much. So what's in this new software system? There was long topics here in, but I want to focus today on this small, thin layer below, which was named Process Method Tools Framework. And we always name this in one block, PMT, mostly. And we tackle it as one thing. But I think we have to separate those two a little bit more in thinking and also in what they are for. So we have on the left side the way of working, how organizations communicate, how people work together, about the structures and all the processes and methods. On the right side we name it software factory design, also the tools, how we develop the software, what we do. And of course, the organizations define the used tools, and hopefully they're bringing added value. And on the other hand, the modern tools can influence the processes and methods and hopefully create a lived culture. What do I mean with lived culture? There should be no process without an automated tool. Or let's say it in words of a SPICE assessor, if you make your assessment and you take a look to what the people are doing, if they do it just for the assessment or if they really use it. That's the difference. Really using it means there is a tool which supports you in creating some of the artifacts you should do. Okay, that were process and methods and tools. What are the challenges in this area? So there is a study from McKinsey. It's a little bit outdated or old already, but I think it's still valid. It shows our productivity, the productivity of the tech leaders and the complexity of our systems, which is raising. And it was from 2018, I put 2023 in here. Maybe we are a little bit better. Maybe the gap is not so big, but I think it is there. The gap is there. Another chart from Weinberg, from how software is built. It shows the effort and the complexity of the problem. And here it gets, obviously, why we are screwed. So we have an ADAS L2 system. We develop it with the methodology, with our today's methods we are using. It's not one method, it's how we develop the vehicle. And we add now L3, and we see, okay, it works, but everybody's saying, or you face that it's limit. It's very complex, very expensive, and I would ask you, do you know any project which is running very smooth, green, everything is nice? I think we are facing a lot of projects which are decontenting as a result of we are hitting not the deadline of the SOP. We know all SOPs are never moved, but it happens also. And that's because our methodologies are at its limit. We need something new for SDV, software-defined vehicles, L4 and all the others. So we need a new methodology, which may at the beginning now looks more expensive, but which pays off later. There are a lot of more challenges we see, but one highlighting here is we are still in this document-driven approach with requirements and system description, and the feedbacks on architecture, I think it's too late if you have a feedback that something doesn't fit in the vehicle when it's in front of you, so that we need to be faster there. The second area, the tools area. So we have there, I think, the most challenging stuff in AD because of the data. So the data, petabytes of data, transporting the data in time to a hill station, having low latencies. We use data, artificial data for simulation, which is good because they do not need to copy so much of the raw data material, but later you need it. So we need this triangle in sync of software, automation, and data. And again, I think last time I used something from How Google Works, is too old. Now I think it's still valid. We are a little bit the turtles here, because there is a lot of modern IT out we are still not using. Some of the points, this is the lower one. The potential of CI/CD, this tool change and this end-to-end cloud-based development is rarely used. So it's not really everybody is not using it. So the most use is still the developer desktop out there with all the debugger and compilers and all the stuff, which is okay, but I think we should increase the other two. So how we deal with this complexity? And we say the use of real software factories is essential. So last year we presented some of the details of this digital twin, AD digital twin, where we use the virtual environments for the real world to test scenario-based DAD things. And there's a small picture of the software factory you see ICD in. But what is it? And what's beyond? Or let's say, what else happens? So we see there is now something going on in the real plants, in the factories of the OEMs. They introduce with Omniverse here from the press and media for Omniverse with BMW and Mercedes. They do a virtual plant. Why they do it? It's very clear. In the development of such a complex system, which is a plant, you have technical debts, and you want to avoid them. You want to find your problems before you build your production line. Because if you find it in the virtual world of your production, then you can remove it much more easily than later. So it's all around these technical debts you have to avoid. I created some charts, and this is a legend for it. So it's a purple development task, the green one is a test task, the orange one is integration task. So we have final deliverables, and we have, of course, data. And what do we do all the day? Function development. We put in our requirements, quality requirements, we put in data example for training our AI algorithms, and then we have a creation of a customer function. And we output is code, networks, DNNs, and models. And then there comes the test step, the quality gate. test cases, scenarios in, data for testing in, environment simulation in. And of course, if possible, we have a closed loop system. And the output are KPIs on quality and completeness. And we want to have this from beginning because we want to have a kind of development loop. We want to have feedback very fast to the developer. So it means to test fast, to fail fast, reducing again the technical depth in my code or my models or whatever. But the same challenge is, or it's also very, very urgent needed that you get a feedback to the architects. If something is not working well in your architecture, the architect should know this from beginning or very early. As said, if you face some of your architecture decisions were made wrong when your car is in front of you, no way, no chance. So what's in this quality gate? We analyzed it, put it into the context of our lovely V model. So we have all the different levels there, and we take a deeper look to, this is a test plan, for example, and we take a look and say, okay, what can be virtualized with the virtual ECU, with a different level of the virtual ECU from 0 to up to 4. And there's a lot, you see, you can virtualize it. You can do it already before the hardware is available. So means the technology for virtualization is available. We saw it already also with a speech from ANSYS. What's next then? Or what can we do with it? Of course, the shift left. This is for completeness here. We can make more of the testing in the virtual environment, and so we lower the cost for testing. This is one building block, but I think the building block of lowering the cost. But what is more crucial is if we put this now into a software factory. And what we are facing, or what we are seeing at the moment, are single production lines, I would say, for a software factory. We want to, when a code change, a data change, or the architecture changes, we want to build our system. We want to create our deployable. And then we put it on a SIL. We put it in the first way in the software in the loop. And if this is okay, we can put it in a virtual ECU, adding, for example, the AutoSAR middleware, adding hyperscaler, hypervisors, and operating system, and even more. And if this is okay, we go to the real hill. And then we execute it in a very expensive hill environment with all the things. And if this is okay, we hopefully go automatically over the air into our test vehicle, or on our test vehicle fleet, ideally. Or maybe in the consumer fleet, maybe not without additional things we have to do. But this is a software factory, in our view. Creating this starts really when we implement the project. So it starts ideally when you write the first line of code, when you create the first thing out of your requirements, you want to have already a software in the loop framework. Maybe with empty templates, but you should generate the complete picture already. And the more mature your project goes, the more you're ending up in the virtual ECU or on the hill, and later you have your test vehicle fleet. But why is this not enough? You take a look to a normal customer function, and it's not enough because mostly the functions are meanwhile distributed over multiple HPCs. They're on multiple domains. Take a parking function. So one domain software factory is not sufficient. So we need many, because of the many functions are distributed now. And how can we test these decision that we split functions on multiple HPCs? So that's something where we need more. And how does it look? So we have here, for example, our CI/CD overview for a software factory, where we work on multiple repositories. We have multiple pipelines running then container on Kubernetes in the back end and creating output KPI views to it. But that's not all. If you take a look, there are many, many other software factory implementations out. And this is okay. And if we tackle the complexity with self-organization in your big companies, then you will have many implementations. So we need to consider the variance of software factories, the interfaces between them. Because the next step, or the final step from our point of view, is a software-defined vehicle requires to build really large software factories cross-domain. All the software functions of the software-defined vehicle generate their deployables, first on a SIL environment, but then integrated on a virtual HPC, maybe with all the zone architectures below and all the ECUs you have in your vehicle, and finally to have a virtual car. I think this is needed. This is required to develop our complex systems. All functions software that enables really this cross-domain check and feedback about the architecture. Is it running today? No, I don't know. I think no. If somebody would say, yes, I have it already up and running, it would be really nice to get this information. Is it possible? I think yes, if we change something. And this is coming now to the point, we need the development method plus. We need another level. And this tackles now the left side of the V model, so the brainwork part of the design of our systems. And I think the model-based systems engineering approach is a good one. Used here Capella as an example. The pictures are from there, where you have the functional and non-functional needs on the top level, operational analysis, then you go onto your logical architecture. I would add here definitely the software architecture viewpoint to that. That's very important. And then we go to the physical architecture. And not only the physical architecture is required, also this virtual physical architecture needs to be considered from beginning. What you can do virtually, what not, and to plan this very, very early in your process. What brings it to us? Of course, from the document approach, where you have really, really big boundaries between your supplier, you go to a model-based approach where you have a shared model among all of us, and this is, of course, effort, and it's not easy to implement, but it will definitely, besides other, improve the communication and collaboration and create, for example, you can create safety analysis or SOTIF analysis automatically and not really all by hand. These things can be done, and we have outside our experts here, come to that later. But what else is it? It's a shift of the contract API. So let's say contract API between supplier and OEM. We are at the moment, or in the past, let's say we are not there at the moment anymore, but we are on the transition. In the past, that was the API to the communication layer. That where when we have all the ECU as black box and the communication layer was our interface, or the interface between OEM and supplier. And we need to shift this up. I think we need to go to the contract API on software level, because with that, we are able to virtualize all this lovely heterogeneous SoC software stack below. The basics of the hypervisor operating system. With that, we can really do this virtualization very at the beginning of the projects. And what we else need, but I think this is future because that's not done. And if this is done, we should also think about how we can standardize or defining APIs between software factories. There will be multiple ones. That's something you can see at our Luxoft booth. So we created with Enterprise Architect these architecture for an ADAS system. We generate out of that for ROS and for AUTOSAR two different implementation layer, or let's say APIs out of the core architecture. We have the model-based scenario on the side, and then we put it onto, for example, a simulation on Kala. And of course, this can also run in, for example, AWS. And the experts are at the booth. This is, of course, a high-level presentation, but there are so many details behind all of this that would not fit into 20 minutes. So I'm coming to the end and to a kind of summary and call for action. So the summary, I will not repeat all these points I put into the slides, but I have a colleague always say crisp summary. So for managers, we need to develop new methodologies, for sure, to face this complexity we have ahead. So, and one is the model-based systems engineering approach, the software APIs. With that, we enable this end-to-end software factories at scale, really this massive use of virtualization. The overarching goal is to reduce the technical depths in your system. If you have technical depths measured, that would be really good, but I think not everybody is doing it. But if you have the technical depths, when you start integrating, we are facing the big bang integrations, where the problems you're facing maybe not in the root cause of the integration, they may lay in the API or wherever. Too late recognized, that would kill every project. And this is then the enablement or the implementation from actual methods to the future methods, where we are then be capable of managing those complex projects. So call for action is clear. Introduce this quicker, faster, teach our colleagues and our management that what the software-defined vehicle impact is, and also take the model-based systems engineering. And for the colleagues on the purchasing culture front, I would love to change the purchasing culture also. Let's see, long-term thinking and end-to-end thinking. I hope we can train our colleagues there. I'm looking forward to discuss. We have our team here on site, and I would be really happy if you reach out to talk to us at the Luxoft booth. Thank you very much.
That was a great talk. Excellent talk. Thank you for that.
Thank you.
So I think the call to action is clear. I'd love to see questions and maybe comments from the people in this room before we head to lunch. Somebody has to have a thought about that. You were actually asked to do something at the end of this talk. So what are you thinking about it?
Everybody's hungry.
I think so. So one thing I'll point out is in the United States, the Federal Aviation Commission, they put together a study. They looked at this problem, and what they found for software that was on airplanes, to put on airplanes, that 70% of software defects were introduced in the architectural documents. And then it took the software integration step in the development process is where the majority of those are found and eliminated. And I think the reason they're found and eliminated there for aviation is because the requirements are so stringent. I think the risk that we have in our industry, 70% introduced in the architectural phase, and then maybe 30% of those get out in the car and customers are buying them. So I think that there's something to this. I think we really need to think about it. And this concept of shift left and model-based systems engineering is, what I personally think about a lot in my current role. And I'm happy to talk about what we're doing with federal exchanges and big banks to eliminate this problem in those types of systems as well. But please, yes, we have a question.
Martin.
Thank you.
Hi, Martin Schleicher, Continental. I'm not from purchasing, but Karsten, can you elaborate a bit more what you would foresee as changes in the purchasing departments, processes, organization, whatever you have in mind? Thanks.
Maybe not taking always the cheapest, so no. I think if you purchase software wrong, your costs will come later in your project. You will have maybe a cheap implementation or a good one, but if you purchase unmaintainable costs, if you don't put in requirements to the quality and compare, I would say, the cost of the total project. And so at the moment, I think our purchasing people they got their KPIs on lowering the costs in the beginning, but I would wonder what happens if we would make statistics over the whole project life cycle, what at the end is the cost. So if you save it at the beginning, you may spend a double, triple at the end, and really, and giving software value, and more value than it's part of the hardware. And this change we need.
Well, I agree. The value in the meantime comes from the software, not from the electronics. Nevertheless, if you look at the KPIs from purchasing, probably they will pull out ASPICE requirements as the measurement for quality in software. What would you respond?
Yeah, that's a good requirement to have an ASPICE process, but I don't know if then you should prove from beginning that you have also the requirements from your OEM on the quality level of your ASPICE input. So That's not I would say ASPICE is not a supplier issue, it's an issue of the whole. And we know our OEMs sometimes don't write the requirements down, and they can't because they don't know what they want to do in 2 years. So that's why we try to introduce the agile development, t-shirt size, purchasing, and so on. So we all need to follow ASPICE then, also the OEM.
Okay, thanks.
Thank you. So I'll ask a question. I'll frame this as a question, but man, I really want to make it a statement. But I'm going to frame it as a question. So can you speak about that requirement step from the OEM to the tier one or the OEM to the supplier? How much iteration is required once the initial requirements go out to actually refine the understanding of the requirements, to actually make sure the requirements are complete enough that the project can be completed? Can you just talk a little bit about the process today?
I think we are on a transition where maybe, as said, the requirements are not fully clear at the beginning, but I heard about project where 2/3 of the requirements changed from beginning of the project until we delivered. So that's the answer is then this agile approach, but iterating on the requirements, I have no data how much it is, but I heard one statistics 2/3 are changing, and so clear is at the beginning we should know what we want to deliver, maybe in a vision, not in the detail. But the architecture we cannot make iterative at the moment because we have no test environment for testing the architecture as well. Right. We have no virtual car at the moment from beginning. So, and then we see the problems too late, and then maybe we change core requirements from the beginning, which has an impact and a delay of the project. So,
yep, for sure. Thank you very much for that. Going once, going twice. Before I let you go, when we come back, there will be 3 options. One option will be this room with a great lineup of speakers and more of me. The other 2 options are upstairs. They will be upstairs in 2 different, I think they're upstairs. I'm looking for confirmation. The other 2 tracks are upstairs? Yes, they are. So the other 2 tracks are upstairs. Please review the app and pick out the presentation that is the most interesting to you so you can get the most out of the event. So it's lunchtime, networking time. Let's give a round of hands to Karsten. Thank you so much.
Thank you.